Let's take a closer look at ionic bonds. So from yesterday's notes after the quiz, you learned that atoms form bonds to obtain a full valence shell. So just remember that to obtain a full valence shell, you need to have the maximum number of electrons in the outermost orbital. And so to do that, if you're in the first shell, the maximum number would be 2 electrons. 8 electrons in the second shell would fill that. And then in the third shell, you would again need 8 electrons to have a full valence shell, if the valence shell is the third shell. So let's just get right into some examples here. If we have LiF, so when you see 2 atomic symbols written without any spaces, that just means they're bonded together. They're forming a compound. So this LiF, you know that Li is a metal because it's on the left side of the staircase on the periodic table. And we know that F is a nonmetal. And so those two should form an ionic compound. And in an ionic compound, or in an ionic bond, an electron is transferred. It's always transferred from the metal atom to the nonmetal atom. All right, so if each of these wants to complete its, or have a full valence shell, let's look at lithium. So for the Bohr diagram of lithium, we have 2 electrons in the first shell and 1 electron in the second shell. And so what it can do is it can take this electron and it's going to want to give it away. But before we look at that, let's look at fluorine over here on this side. So fluorine has 2 electrons in its first shell, and in its valence shell it has 7. So fluorine needs 1 electron to fill its valence shell. Now if lithium, we can say lithium loses 1 electron, and when it does lose 1 electron, you can see that shell underneath its valence shell then becomes its new valence shell, and that would be now a full valence shell. So when it loses 1 electron, this inner shell becomes the valence shell. Okay, and so this electron becomes transferred, or it gets transferred to the fluorine. And so let's look at the Bohr diagrams for what happens after that transfer occurs. All right, so now we have our new lithium, and because it lost an electron, it's now called an ion that we learned last unit. And this lithium ion has 3 protons, but now it only has 2 electrons. So if you have 3 protons and 2 electrons, you have an overall positive charge. And so to represent that on the lithium, we put a little plus sign. Now looking over here at the oxygen atom, it gained an electron. So it gained this electron right here. And so oxygen has 9 protons. And if you count all the electrons in that Bohr diagram, it has 10 electrons. So this has an overall -1 charge. Sorry, that's not oxygen, that is fluorine. So fluorine has a -1 charge, and so we put a little minus sign above the fluorine. And remember, if you have a positive, so this is a positive ion, this is also known as a cation. So cations lost electrons. And then this is a negative ion, also known as an anion. So the lithium transferred one of its electrons to the fluorine so that it has a full valence shell. So this first shell has a maximum of, it has its maximum of 2 electrons. And then the fluorine ion on the right side now has its full valence shell as well. Okay, let's look at another example. So now we have MgO. So magnesium has 2 valence electrons. Okay, but underneath that third shell, there is a full valence shell. So we want to kind of reveal that shell and use that as its valence shell. Whereas oxygen has 6 valence electrons, and so it needs 2. So remember, the electrons are always transferred from the metal to the nonmetal. So in this case, magnesium is our metal, oxygen is our nonmetal, and you can tell because they're on opposite sides of the staircase on the periodic table. So in order to complete its valence shell, magnesium loses 2 electrons, and oxygen needs to gain 2 electrons. And so what happens is we take this electron, and they become transferred over to that oxygen atom. And so if we look at what happens next, here we have our magnesium, and it lost 2 electrons. So it has 12 protons. And if we count all of the electrons in this Bohr diagram, you would get 10. So we have 2 more protons than electrons, so that means the magnesium now has a +2 charge. And in chemistry, we usually write the number first, so that we would say Mg and then 2 plus as a superscript up there. Now for oxygen, oxygen gained 2 electrons, gained these 2 right here. So oxygen has 8 protons, and it has 10 electrons, giving it an overall 2 minus, or -2 charge. And just like magnets, if you have opposite charges, they will attract. So the magnesium has a positive charge, the oxygen has a negative charge, and so what causes that bond is those opposite charges. So now this negative ion, or this anion, and this cation, they feel an attraction between each other because they have those opposite charges. We can say they are attracted. And so this is an ionic bond. Because of those opposite charges. All right, so let's take a look at one a little bit more complicated. So now we have Li2O, and this 2 just means you have 2 lithium atoms. So there's 2 lithium atoms in this compound. That's what that little subscript 2 means. So these are the Bohr diagrams for lithium. You can see there's a single electron, again, in the valence shell. But underneath that shell, in the first shell, there is a full valence shell. So we need to kind of reveal that so that it has a stable outermost orbital. And so each of these lithium atoms will lose 1 electron, or it's going to lose the electrons in its valence shell to reveal that full shell underneath. Whereas oxygen over here has 6 valence electrons, and so to gain, it would have to gain 2. So this, oops. So this needs to gain 2 electrons to complete its valence shell of 8. So we call that the octet rule. So this needs to gain 2 electrons to fill its valence shell. So again, it's going to kind of be like the same idea as before. So this is going to want to, this lithium atom is going to want to give away its electron this lithium atom is going to want to give away its electron, and because this oxygen needs to gain 2 electrons, it can actually take both of the electrons given away by the lithiums. And so again, we have our anion, and this oxygen will have a 2 minus charge because it gained 2 electrons. And each of these lithium atoms lost an electron, so now they are lithium plus, and these are cations. Okay, now rather than drawing Bohr diagrams like these for every single atom, what we can do is we can draw Lewis structures just to make our lives a little bit simpler. So the first example we did, we had LiF. Now, rather than drawing Bohr diagrams, what you can do instead is we can just write our Li, and it has a +1 charge. Now we can draw fluorine, and after the transfer of electrons, fluorine now has 8 valence electrons. And so when you draw a Lewis structure for something that gained electrons, you put brackets around it, just like this. Okay, and then because it gained an electron, we put a -1 charge. And so this is the Lewis structure for an ionic bond. All right, so again, I'm going to go back up to our first example that we did with Li and F. So rather than drawing this giant Bohr diagram every single time we're trying to represent a bond between a metal and a nonmetal, we can draw a Lewis structure instead, so it just makes it a little bit simpler. So MgO, Mg, we said lost 2 electrons, and so it would have a 2+ charge. Oxygen now has a full valence shell, so we draw the valence shell around oxygen, and because it's the nonmetal, we draw our brackets around it, and it gained 2 electrons, so it has now a 2- charge. So that would be the Lewis structure for MgO. Now for Li2O, we have to do something a little bit different. So we have our Li, draw its little charge next to it, and because there's a 2 of them, we put a 2 out in front of the lithium like that. So now we have 2 lithium ions, and then our oxygen. So you draw the valence shell around the nonmetal, and you leave the metal blank. And oxygen, because it gained 2 electrons, now has a 2- charge. So all of these are this is how you draw a Lewis structure. So when you're drawing the Lewis structure, the metal, so for the metal, you draw the charge. For the nonmetal, draw the full valence shell. You draw the brackets as shown above, and then you draw the charge.